Hello everyone, welcome to another video of Everyday Learning. In today's video of probability and statistics, we are going to practice a problem from the topic expectation. Now we are going to continue the problem that we did in our video for the discrete random variable, which is 2.1.1, and we will be continuing that problem in this video. Now I'll stick the link of the previous video in which this problem was solved and we obtained this table, and continuing that we will do today's problem. Now in today's problem we are said to consider the 4 copying machines discussed in the previous problem, this one, and we are asked to determine the expected number of copying machines in use at any particular moment. Now for that we need to at first know the formula for expectation. So this is our formula for determining the expectation value. Expectation generally means the mean or the average value taken by any random variable. So the expectation or mean or average by any random variable x is equal to summation of the probability values and the values taken by the random variables. So in this table we are given the values taken by the random variables and the probability values. So it is very easy to determine the expectation. Therefore, expectation of x is equal to 0 into 0.08 plus 1 into 0.11 plus 2 into 0.27 plus 3 into 0.33 and finally 4 into 0.21. So according to the formula, you can see that we just multiplied the values taken by the random variables with their corresponding probability. You can see them in the table given above. So if we do the calculation, we'll end up with 2.48. Now the interpretation has to be mentioned for this value. Therefore, the interpretation is that the expected number of copying machines in use at a particular moment in time is equals to 2.48, which is wanted as our answer. Alright, so this was determining expectation for discrete random variable. Now we'll practice one problem for continuous random variable. So we'll take this problem for practicing the expectation of continuous random variables. Now we are given a problem in which we are given the thickness as the random variable taken by the color on a panel, and we are given the function of x, which is the PDF, and we have an unknown constant here, a, and we need to determine the value of a first in order to determine the expected paint thickness. Now we know that CDF is equals to integration of PDF dx. So here we are given f of x is equals to a into 0.5 minus x minus 0.25 squared. So in order to find the CDF, which is capital F of x, what we do is integration of a times 0.5 minus x minus 0.25 squared dx, and we have the limit extending from 0.125 to 0.5. Let me mark it for you. This one is the limit given. So the limit is 0.125 to 0.5. So if we consider a as a constant, then we have 0.125 to 0.5 and the remaining portion. So if we do the integration, we'll get the result of this part as a into 93 over 512. Now if we determine the CDF, we know that this final value of the CDF is always equals to 1. So we can write that a into 93 over 512 is equals to 1. Therefore, A is equals to 512 over 93. Alright, now we can determine the expected paint thickness. Before that, let me write down the formula for expectation. So this is the formula that we can use to determine the expectation of continuous random variable. E of x is equals to integration of x times fx. So we just have to multiply the variable x with this given expression to determine the expectation. So let me move a bit down. Therefore, expectation of x for this one is equals to integration from 0.125 to 0.5, the limits that we have got, with x into the value of a, which is 512 by 93 that we determined here, into 0.5 minus x minus 0.25 square dx. Now we just need to do the integration. Alright, so this is how the integration can be done. I skipped the integration parts explanation as this is not an integration course. So if we do the integration, we'll end up around here, and if we put on the values, we'll get approximately 307 over 992. This is an approximate value. So by determining the expected value using this formula, we end up with this value, and the interpretation states that the expected or the mean or the average value taken by the paint thickness in this case is equals to 307 by 992 millimeters approximately. Hope you could understand how to determine expectation for discrete and continuous random variables. If you have any question or confusion, feel free to write down below, and thank you for watching our video.